Okay, so I created this video to actually show you some of the things that I saw that you guys are still having challenge. Um, the thing that I want to actually talk about here, the thing that I want to highlight is this normalization. When we normalize to find the normalization constant, and you can see that you are given a wave function xt, and that wave function is going to be equal to n sine kn x e to the minus I e n t over h bar. And that wave function is defined from 0 to a. It's defined from 0 to a. So to actually normalize a wave function, this is what you should know. Normalization. It's about normalization so that you can be able to answer this on your optional test. Normalization. When you say, or when they say you must normalize a wave function, to normalize a wave function, it means you will say the integral of, or from minus infinity to plus infinity of the wave function can be x or xt. It's up to you. You can write the wave function of x or the wave function of xt squared, right, is equal to, before I can say equal to here, there must be dx, right? There must be dx. This will be equal to 1. That is going to be equal to 1. So it's the wave function xt. You can see here that this is the wave function xt squared dx equal to 1. So you must be able to find this. You must be able to find this. I even indicated in our previous session that you must, or you can start by finding what? This wave function xt squared. You can start by finding this. And then after finding this, you will substitute it back to the integral so that you can be able to get the integral simply. So what do I mean by that? When you normalize a wave function, now I'm going to do an example. Okay, before I do an example, another thing you must know about this says this thing, this wave function xt squared is equal to, when you calculate this, it's going to be the wave function star, which is the complex conjugate of wave function times the wave function itself. That's another thing you must know. So how do you get a complex conjugate of wave function? It will depend on the wave function that you are given. which by now, let's say we are going to do this example. You are given this. You are given this. Wave function xt is equal to n sine knx e to the minus I ent over h bar. So you are given that is the wave function x t equal to n sine kn e to the minus I e. Let me see. This is how it is. ent h bar. Okay. It's ent h bar. So it's en times t over h bar. And it's defined from 0 to a. And they say it's what? In infinite or 0 elsewhere. They say it's 0 elsewhere. So it's 0 elsewhere. So in this other part, it's 0. So we don't care about this other one. So we're only going to care about this one. So what does it mean? Now, they say normalize every function to get this constant n. So that was the question. Normalize the wave function. Just say wave function to get the constant n, right? Which is this one. So how are you going to do that? When you normalize, in most cases, actually, in every case that I have seen before, the reason for normalizing is to get the constant, to get this constant. So in this case, I told you that when you normalize, you're going to use this formula, right? It's a call. You're going to use this formula. And in this formula, you can go and get this. And this, I said, is what? Is this. I said it's this. So now you can see that this is one is the same as the original wave function, and this one is the complex conjugate of that wave function. So how do we get the complex conjugate of that wave function? How do we get it? How do we get it? How do we get it? Get the complex conjugate. The complex conjugate of the wave function xt complex is equal to what? N sine k n e to the I. Now you can see what is happening now. Here it was minus, right? Here it was minus, but in here it's going to be plus, which I cannot write plus, so I'll just write I, and then n t over h bar over h bar. Then because we have the wave function star or the complex conjugate of the wave function, we can now go and get this, right? which is going to be, I said, the function of xt squared will be equal to the function star, which is this, right? It's going to be what? N sine kn e to the I e n t over h bar, right? Multiply by what? The wave function. The wave function itself is n sine kn e to the minus I e n t over h bar. And then what is going to happen now? What is going to happen now? You have this and this. They are going to cancel, right? You have this and this. They will square. You have this and this. It will be squared as well. So the final answer in here final answer will be given by, or the value for this is going to be n squared, n times n, right? And then sine kn or sine squared kn, sine squared kn. That's your wave function xt squared, right? And then what are you going to do now? What are you going to do now? You're going to substitute this to the equation, which is that one. So it's going to be the integral. Because now, so I want to say the integral from, because now this is from 0 to a, right? What does it mean? It means you have to say this integral is from 0 to a. You will not say from minus infinity to plus infinity. You will write 0 to a, right? Of what? N squared sine kn. This is also squared g x dx equal to 1. So I substituted this. I substituted this inside the wave function itself. And then now I want to get what? I want to get this normalization constant. I want to get this normalization constant. So now what is left to do now here? What is left to do now here? You have to integrate this whole thing with respect to x. You can see here And what does that mean? Whatever that does not have x is going to be your constant. I hope you can even see it here. So yeah, whatever that is not a constant, it is going to be. I think I made a mistake here, which I know you can be able to correct here, in here. Because the reason that you understand is the reason that you will understand why I'm k and x e I e over h bar x, and then even here it has to have x, right? There must be an x here, to the minus I. This one is going to be to the I, right? E over h bar x. So that x must be there. Even here, in here, there's an x. There's an x, right? E to the I, E n t over h bar. Okay. And then now, because we can see what's happening, it means here is going to be what? K and x. Okay. And then also here, there's k and x. So I just missed this k, this x, and it's very important to have that x there. Okay. Now you can see that this is a constant because we're integrating with respect to x, and this sign is sine squared k and x. So this k and x is an angle. So it means we cannot take out this sine kn and then be left with x. So this is a one thing. Sine squared kn x is a one thing. So in this case, we are going to have n squared from 0 to a of sine squared k n x dx. Okay. And then here now, this one, it's what you have to keep in mind. It's one of the integrals that you must keep in mind. The one for sine squared. The one for sine squared. You must keep this in mind. But this thing is going to give you. Okay, let me give you a record from. hope you can see it here. So this sine squared kx is going to give you what? X over 2. It's more like x over 2. It's x over 2. So I don't advise what someone can claim. I don't advise what someone can claim this, but because it is only one, only this one that will come like this. If it comes like this, you have to know the integral for this sine kx, sine squared kx dx. It's going to be x over 2. So it's going to be n squared multiplied by x over 2. Sorry, x over 2 into what? From a to 0, or from 0 to a. It's equal to what? 1. And then from here, you will have what? This one like this. It's multiplying, right? N squared into, where there is x, you put a over 2. Minus, where there is x, you put 0, equal to 1. And then you will have what? N squared. This a over 2 minus 0 over 2 is going to be a over 2 equal to 1. And then these 2 cross multiply, right? So it's going to be n squared equal to 2 over a. Then n equal to square root of 2 over a. That's your value for n. That's your value for n for this normalization constant. And that's how you get it. Okay, good. Let's meet again in the next session. I'll record another audio for special cases like this.